Well, good afternoon, everybody. And this is USB. I'll look inside. I'm Chris Otto. My colleague who was supposed to co-present with me today, he got some sort of like stomach weaponized Ebola or something, so he's not able to make it. And he sends his regrets. But what I'm going to cover today is a bit of USB background, a little bit about HID devices and descriptors, as well as a bit of a note just about firmware in general, because almost every USB device has to have some degree of that. And the part 4, which I hope was the most interesting, will be trying to exploit a standard HID driver. So in part 1, I call it the Martini background, because this stuff might get a little bit dry, but do bear with me, as this stuff, it is important. And it'll be relevant once we actually get to the exploit. So with USB, one of the advantages to it is that it has a process called enumeration. And this is basically USB discovery. Every single device that talks on the USB bus does so via setup packets, but it also does so to establish who it is, what it is, its type of configuration, and also how it's supposed to talk. But this particular process is very trusting. So the host will actually ask the device and say, hey, so what are you? And the device can come back and say really anything it wants. So I could have a flash drive that says, I'm a mouse, and it says, great. I'm also a keyboard. Absolutely. I could say, hey, I'm a tree, and it says, sure, why not? As long as your bark is not as bad as your bites, right? So at the end of the day, this is where the process is very useful, because you can take any device and plug it into any system that supports it, but because it's very trustworthy, you can also take advantage of it. So here's a very typical setup packet. And within this packet is where the host will send most of its requests to the given device. And a lot of this is just a very simple bitmap with various requests like, please can I have your descriptor, as well as your configuration and so on and so forth. Yep. Oh, I'm sorry. Let's see if we can get this working. That was working before. Say this one. No? Yes, no. There we go. How's that? So we covered the overview. There's a Martini background, to recap. Back to enumeration, and now back to the setup packet. So, well, it's not my laptop. But with this setup packet, most of this stuff is done on the initial setup channel. And this is always, the host always initiates, and it's always done through this particular format. Now the formats that come back are the device descriptor, configuration descriptor, interface, and endpoint descriptors. And this basically makes up the crux about how USB communicates back and forth. Everything comes from the root of the device descriptor, and you can have multiple configuration, interface, and endpoint descriptors, such as I'll show here. It really is an enumeration tree. So depending on the configuration that you want or the interfaces that you want to set, you can have multiple configurations set up within any sort of given device. And that goes back to saying, hey, I'm a mouse, I'm a keyboard, maybe I'm sending data one way, and now I'm a bulk device trying to send data a different way. So here's what sort of comprises the device descriptor. Now, for the most part, this really doesn't mean all that much, except that this is probably one of the more important descriptors that exist. Because if you've ever looked at the device manager in Windows, most of the information you see from that comes from this. If you look at, say, the offset between 4 and 6, as well as 8 and 12 there, Windows, when it goes to try and determine what driver should I pair with this given device, is it a boot device? Is it just a standard mouse? Is it a device that I already know about and I already have a driver for? This is where it happens. So here's like your typical device manager, and we have plugged in a Microsoft mouse. So I'll zoom in there, and the top part, if you've ever bothered to wonder, is you have the VID, PID, as well as revision number, and that all comes from that device descriptor. And it's the same way in Linux as well. So here we have the configuration descriptor, and the configuration descriptor comprises both the interface and endpoint descriptors. And it's important enough because you can have multiple configurations, and it's, well, it's important either way. So the interesting thing with the interface, the descriptors, is that it controls your endpoints. And realistically, like USB is just serial data going through two wires. And so that can be formatted in any way you like. And the interface to the descriptor, especially with the B alternate setting, you can have a given setting, but also have alternates. And with the alternates, you can also set different ways of communicating with your device without upsetting the entire configuration. And last but not least, we have our endpoint descriptor. And with our endpoint descriptor, it determines the endpoint address. It determines whether it's since they're unidirectional only, are you going to the device or from the device, and what number address are we actually talking, as well as how many bytes are meant to be going through this particular device. So if I had a VoIP phone that was HID compatible, I could have a data stream for audio going one way, audio coming back, as well as a data stream for, say, the numerics or the keypad. And last but not least, the transfer types. So there are four major transfer types that comprise USB, and that's the control, interrupt, bulk, and isochronous. Or the asynchronous. The control type is important because all of your setup types are always a control type, and that has to be supported by any and every USB device. Your interrupt type is mostly if you're doing an HID descriptor or a mouse or a keyboard, because the interrupt type allows for polling every so many seconds, and that's what it guarantees, but it doesn't necessarily guarantee your bandwidth. Whereas your bulk will allow whatever the remainder is, but it will drop packets if it so sees fit. Whereas the top it has guaranteed bandwidth. So if you're doing, say, an audio stream or a video stream and you're absolutely sending data across, that is what you would use. So now that we have kind of the basics, let's talk a little bit about HID and why it's important. So HID descriptors. Basically, HID is a human interface device. And what that means, it's a set of groups or controls, or at the end of the day, it's a format of how your data is being set up and formatted by both the device and allowable by the HID driver. So because you're not going to have a driver necessarily for every single mouse out there or every single keyboard out there, you want to be able to have something that can just say, look, my device sends data in this format. And as long as you can read it in that format, we'll both be friends. So with a mouse as an example, which I'll show in just a little bit, the second byte is usually the x-axis, or the y-axis is usually right after that. And then you can also define what range of values are appropriate for that device. So if I have 255 hex or if I have FF hex or whatever, does it mean -1 or does it mean 255, depending on what's important? Because if it's defined wrong and you had a mouse that was absolute, you would only be able to go down and right, and that's it, never up and left. The thing with HID, it's also used beyond USB as well, in some Zigbee cases, in Bluetooth, and in others. So it's a little bit bigger than just the realm of USB, but this is the part that we're going to try and exploit a bit later. The thing about HID, because it's a very long and well-defined spec, is that it has several pages or definitions, because you have to appreciate you don't know necessarily what device is going to be coming in. So to make things easier, inside your descriptor, you say, this is the page I'm working with, and therefore within the descriptor itself, certain numbers will then mean certain things, and it just helps out both the driver and the host, or device and the host, sorry. So we have everything here from VR controls, sports controls, battery systems, and even generic desktop controls, so on and so forth. So in this case, if we want to define a simple mouse data format, so on the left side, we have both, the in and out descriptors, in being from device to host, and out being from host to device. And the in, on the left-hand side, we have buttons. In this case, there really are buttons 1 through 5, but they're bits 0 through 4. And on the 3 next to it, they're just don't care conditions. So that way you could send a byte of data through that, and the first 4 bits will actually have some degree of meaning. And the X and the Y and the wheel, we want to have set up as a plus minus 127 approximately. So that way it's relative. You can go up and down from your current position. Unlike perhaps a positional device where it wants an absolute position at all times. And in this case, we also have one out descriptor, which I just refer to as data, which you also can have vendor-defined pieces of data that the HID descriptor, for the most part, will ignore, but will also allow and just put in anyway, but will not necessarily be used by a standard driver. But if you know where it is, you can certainly use it. Now, this is very hard to read, but this is what a full descriptor actually looks like. And this would be just to define what we just showed on the previous screen. Now, this is somewhat complicated, but I'll just take a little bit away from it. So if you remember the first part with just the buttons, or just by the in sign there, this is the part of the descriptor that actually defines that. So what we have our proper usage page, and we also have the usage minimum and maximum, because we can order them in any way that we see fit, as well as our logical minimums and maximum, which says either it's on or off, and then our appropriate report count, which turns out to be 5 for 5 buttons. And then below that, we just have a report count of 3 for just unneeded data, unless you want to have 8 buttons in our device. So just to summarize on the first part, the USB devices, the enumeration process is very important because that's what makes USB USB. And it's a very, very trusting process, and that's the part that is easily, potentially exploitable. And just remember that the descriptors, device, config, interface, and endpoint. And it always in that order because you always will see it. And because HID descriptors allow for universal access, which we just sort of described. So on to part 3 here, I want to give a little note about just firmware in general. So in general, when you plug something into your computer, you're expecting your firmware to act perhaps more like Professor Frink here. Something maybe a little wacky, but generally it works to what you expect. Unfortunately, because you really can't see what's inside the machine, you might get this instead. And it is relevant because bad firmware, like the guy on the left, is a little bit bloated. It hangs around or has hung around with potentially not so nice people. And in spite of itself, it somehow manages to sort of keep running. So that is what it is. Thank you. Now, just a note that for some previous exploits that have happened through USB, one thing that HID allows is, or are compound devices. So you can have a device that, as I said before, is both a mouse, a keyboard, a joystick, a VoIP phone, and whatever else you want to attach to it. But it could also be attaching, say, a USB flash drive attached to a keyboard, something that probably shouldn't be there. But so if you plug in a keyboard, all of a sudden a flash drive pops up, and then Windows either runs something from Otto run the IIe or whatever. Also, the thing is, we also had a case where we had USB chargers that are a little more than just USB chargers. This was the case where I was reading online that someone just plugged in a BeagleBoard onto the other end of a charger. So you plug in your iPhone thinking that you're just getting power, but because they have all the connecting wires, you don't necessarily just have to have power on the other side. And the group that did this claimed that they can easily get into an iPhone with under a minute or so, which perhaps is possible. The other one that I found was interesting was a patch that Microsoft had made recently this year due to bad flash drives somehow gaining root access. And that was done through custom device descriptors. Now, I'm not 100% sure how they did that, but I do know that from my own tinkering, from building USB mice and such, a bad device descriptor can cause a kernel panic in about 3 seconds. So it's very easily done. So that's just a small example of what is possible because, again, USB is very, very trusting. But just as a side note, if anybody is part of the tinfoil hat crowd and is really worried that the next thing you plug into is a BeagleBoard instead of just regular power, you could easily buy a Type A female to the Type A male dongle from say Monoprice and just scratch out the two middle contacts, because then it's impossible for anything to transfer from something unknown to your computer, and you can plug that in anywhere you want and just get power. Yes, essentially, yeah. Maybe because that's actually, someone has actually made that, something where they switched it around. But this one, if you're, have a bit of time, is a little bit cheaper. So now here we are, to the fourth part, and we're going to try exploiting the HID somewhat. So I've come up with kind of just a fictitious little scenario. Now, how realistic it is debatable, but what I'm trying to do is, if I'm looking to procure some data from a Linux device, ideally trying to not to set off as many tripwires as possible, and how could I use just USB to be able to quietly remove the data from a given target. And in this scenario, the target that we're going to be looking at, the office environment or wherever it is, all happens to have Microsoft mice, because they got a really good deal or something. So what we're going to do is try and spoof that and see what happens. So here, this is our target mouse. Standard issue Microsoft mouse. Probably you guys have seen this type before. Nothing special about it. It's very straightforward. The mouse data format is roughly what I showed before. We have our, this is actually slightly wrong. It only has three buttons to start, but for this scenario, it could be 5. And just an X, Y, and a wheel. Nothing special, but only one way in. This is my mouse. I had roughly a weekend to put this thing together, so I whipped up a USB mouse out of spare parts. And for those who are curious, this thing is running off of PIC 18F4550. It's one of the few PIC devices that do have USB embedded inside the chip. And essentially outside of the trackball that you see below there, everything is running inside of the chip and nothing else. Now, granted, it's a touch unwieldy, but it does work. I think mine's a little more ergonomic personally. Now, our mouse that we're going to try and do for a bit of an exploit, in quotations, is going to have the same input format as the previous USB mouse. The difference is that we're going to just add in a slight out report. So now, once we've added this, we have the potential for doing two-way communication, which normally you're thinking, well, a mouse should only be one way, and that's true, but now we can send potentially data to it as well. So here's my artist rendition of the device in the field. I mean, I have an imagination, what can I say? But so before we go on, here's some useful Linux USB notes, because we're going to try and do this exploit under Linux. And there's basic commands if you haven't seen them before. One of them is lsusb. We're going to see it hopefully in the video, which just lists your USB device. If you do a -v, it gives more of a verbose listing. One of the things that we use here that I'm very thankful that Linux provides is the /dev HID raw. And depending on the bus that it comes from, it'll be HID raw 0, 1, 2, etc. And now the nice thing about this is the data stream that results from the direct kernel, the direct enumerated output from the HID device. So basically, once this part here has been enumerated, the data that comes out of this will follow this format. Other useful parts that we'll be using just to look around are USB mon or USB monitor, which is handy. Through that, depending on which part you either concatenate using the cat command or such, you can actually see just raw USB data flying through the ether, so to speak. Essentially, this is, I think, what Wireshark uses or something thereof to actually capture USB data. Device, which is useful, or another command, sorry, is the USB devices. What that does, it actually just lists its, by where the USB mon is, where that path is, there's a small file called devices. And what that does, it actually has a debug listing of all the USB devices that are there, plus all of the names and such. Because going back to the configuration part that we talked about earlier, there's also something called the string descriptor. So all the string information comes from that, and it's defined within those descriptors as well. And then from that, that's where it actually lists some of that information. So if you see Microsoft Wheel Mouse, that was actually defined within the device and not necessarily within a driver. The other one that is of interest is USB HID dump. What that does is that if you have a device descriptor or HID device descriptor, it will actually list what that information was for the given device. So that could be handy if you were, say, profiling devices, or just were curious to see what was actually inside that device. So how this works, what we're going to do is, because we have already enumerated our system, we're going to use directly dev HID raw, in this case HID raw 2, because it's on sort of the second bus, to actively read, write data, just strictly using cat. So if we want to write, we cat the file to that dev, and if we want to read it, we just sit there and just read. Now, all the code for this is all set up on the PIC18F, and there's nothing else. All we do is just cat a file in and cat a file back. So what we're going to show in the video, because it may not be easy to see in the back, is that the output of the LSUSB will show for both the PIC18 as well as the MS mouse. And what I'm trying to show is that they're identical. If you were to look at them side by side, unless you looked at them in a very verbose mode, you're not going to see a difference. So they're essentially spoofed. What I do show is that when I do look at it in more detail, the difference is from the one that has no endpoint to the other one that then shows the endpoint that exists, but still has that MSID. Because it's supposed to be a really big no-no to go and spoof another person's device. Now, the other thing is, after that, we are going to show that the HID output is exactly the same for both the Microsoft mouse and the mouse that I built. So I will actually move the mouse around, and it'll produce something, and then I'll move my mouse around, and it'll produce basically the same data. So it shows that there's nothing special about that data stream whatsoever. Then after that, what I'll do is I'll be listening on that port, and I'll actually show a predefined encrypted, well, not encrypted message, but a predefined message coming straight out of the USB stream. Out of the USB data stream that is actually readable. And last, we'll actually show the file being written to the mouse directly and then acquired from the mouse. So hopefully this works. It's kind of a silent film, so I'll try and talk through it. So what we see here is that my device is already plugged in, and it's a little bit hard to see, unfortunately. But what I do is, this is under VMware, so I just virtually plug in the other device, and under there we have USB MON, and that was an enumeration output. And as we can see for both of these here, they are identical. When I actually made the movie itself, I kind of got them mixed up initially. So it just goes to show that they're very similar. So next, we'll talk about or show the mouse device descriptor. So here's the output of ls USB-V. As we can see, nothing special. It's just your standard USB device descriptor with a different, perhaps, data length, but only showing one endpoint that is data in with about a 4-byte payload. Next, we'll show the mouse that I made, and here's its output. As you can see, almost identical. Now, I didn't try too hard to actually make it identical, like with the length was slightly different, but it's very, very close. The main difference here is that we have our input endpoint, and we also, if you notice, we have our output endpoint quietly attached to the rest of it. And that's what we'll use for the file load. Now what we're doing here, if you look at this part of the screen, here I go and I move the one mouse, and from USB MON, there's your data output. And now I go and move the other mouse. Eventually, there we go. Same data output. Granted, it's on a slightly different bus, but the format is exactly the same, and that's the point. So here I have piped in, I've done a cat of the HID RAW2, just pipe it into XSD so we can see what the output is. So this is listening directly to the raw feed of the mouse. And it's only listening to my mouse and not the other one. And as you can see, that's the raw HID output. But on the flip side, though, is that once I stop that and just listen to it or just do a cat direct without the benefit of XSD, and type very slowly, and now I go back and sort of press the secret button on a device, and if you notice, if you can read it, it says B-sides directly through the data stream. So, and that was taken directly through the mouse data stream itself, nothing special, but it wasn't a mouse signal, even though the mouse moved at the same time, which is kind of funny. So here I am, catting my testdata.txt, and within there it has a payload message, which is a super secret message in a text file. And now what we'll do is that we'll take that and pipe that directly into dev HID RAW2. And if you look at the lower left, you'll see the message actually being sent through, but now it's loaded on the mouse. And from here, we'll actually do a file retrieval. So now I'm listening directly on the raw feed, and I'll go and do the load command again, and voila, there's your message. So I've effectively managed to hide a message through a mouse and retrieve it from that same mouse. And I think that's just about it. There we go. right, let's get rid of this here. Sorry. Rick has a very non-sensitive keyboard here. Oh, crap. So one more slide to go, and that'll be about it. Oh, man. All right, almost there. Technical difficulties. 1 second. Oops. There we go. Sorry, it's a little bit skewed. There we go. So here are our caveats, and basically, this how much do we have to worry about a device like this being out in the wild? Well, it is possible. I mean, I built it within about a day or so on my spare time, so it's possible. But still, someone has to build this thing. So if you're really trying to transfer data, you really have to want to use it in that fashion. Also, in order to get direct access to anything within /dev, you still have to have some degree of elevated access. So it's not totally open. But chances are, if you're going through this trouble, you probably already have or know how to get that access. And at the end of the day, it's still easier to create a bit of a compound device or something else with maybe more of a better exploit. But something like this still is somewhat feasible. It's hard to see here, but this is some of the bibliography I had. If you're actually interested in USB, there's the book USB Complete by Jan Axelson. Fantastic read. It's the USB Bible in essence, as well as other things like the HID spec or the HID class definition spec, as well as USB in a nutshell. All very good sites. And that's basically it. So unless there's any questions, I don't think there's too many. I think everybody's kind of hungry right now, so thank you very much.